Howdy folks, Mr. Reed here, and welcome to one more question. So tonight I decided it would be a good idea to just try to derive the logarithm rules that allow us to simplify logarithmic expressions by taking advantage of some little facts that we can show are true. I don't actually even remember which ones I should be doing, so we're going to hope that things come together here as I record this video. So, if you want to see logarithmic rules being derived, you're in the right place. So let's get to it. All right, now, we're going to start with this one because this one's in my head right now. Log base c of a plus log base c of b. We want to show y that's equal to log base c of a times b. So what I'm going to do is I'm actually going to come up with two expressions that I'm going to create some new variables. It's going to allow me to write things a little bit differently than I have them currently, and it's going to be helpful to me to allow us, or to kind of proceed further in this question. So I'm going to say that this first part right here, I'm going to call that x, and this second part here I'm going to call y. And so if that's true, that x is equal to log base c of a, then I can write this logarithm in its exponential form. So the exponential form would be base c to the power of x is equal to a. So I just come up with that expression as a rearrangement of this new letter that I've introduced to be the same thing as that first expression, log base c of a, and that's x. So I also have y is equal to log base c of b. And if I rearrange things the same way, so that would be c to the power of y is equal to b. So what is definitely true is if I start with the expression on the right of my initial thing that's going on up top, I want to be able to show that the thing on the left is true, definitely, if I start with that other expression. So I'm going to say that log base c of a times b is the same thing as log base c of c to the x times c to the y, because my a is c to the x, my b is c to the y. Now, this is only true, of course, because I have picked x and y to be equal to these certain things, but that's fine. I haven't done anything weird here. All I've done is given a different expression for what's inside of the logarithm. So the reason that I might want to do this is because exponentials have rules that we've already developed. Now, if you feel like you've developed them properly for whole numbers and you might not have done it for real numbers, for the exponents, that may be true, but it also does work for real numbers, and maybe I will take some time at some point to try to show that that's actually the case. But for the time being, we're just going to say we're going to use our old normal exponent laws. So we're going to say that same bases multiplied together would be the same as if we were to add those two exponents on a single base of c. Great. I did miss my c on my base of my logarithm. Now, something that's really cool about logarithms and exponential functions, the whole idea of the logarithm, if you take a look at one of my last videos, is that it is the inverse of an exponential function. So inverses undo the original function. So if we have a function and all it does is add 4, then the inverse function is subtracting 4. So whatever value we start with, you add 4, and then the inverse would subtract 4 from it, take you back to the original value. If you put something into the exponent on an exponential function, and then you take a logarithm of the same base, it undoes it. And the same thing is true if you start instead with a logarithm of a certain base and you put an exponential function inside of it, you get back the original value there as well, because they are inverse functions. And we showed that by coming up with the idea of a logarithm by switching the x and the y value algebraically, and then just kind of showing that we can use new notation to show what that actually means in terms of a logarithm. All right, so because the log base c is the inverse to an exponential base c, what happens is those two pieces undo each other completely, and we're left with x plus y. Now, that is all well and good, but I made up x and I made up y. So I'm going to replace those with the types of things that I had with the initial statement. So my x, according to what I have up here, is actually log base c of a, and my y is log base c of b. So what we've done is we've started with this expression, which is actually the one I have on the right to begin with, and we've shown that it is the same as the expression on the left. Therefore, this is true as long as we have values that work. So, I mean, you can't pick c values or bases that don't actually make logarithmic functions. So your c value has to be greater than 0. 1's kind of garbage, but the other values are okay. And then the values inside of the logarithm have to fit your normal domain restrictions for a logarithm. So they have to be values that are greater than 0 themselves. If that is the case, then this should always be a true statement. So I guess we can say logarithm law number 1. If you want to add together two separate logarithms of the same base, it's the same as having one logarithm where the insides of those separate ones are multiplied together. Really nifty. It can be used to simplify expressions and solve eventually some logarithmic based equations where you need to do a little bit of tidy up this way first. All right, so that is thing number 1. We are going to go for a very similar expression next. Log base c of a minus log base c of b is equal to log base c of a divided by b. To be honest, if we pause the video here, you should have a pretty fair chance at getting showing that this is true by following a very similar pattern. So you could do that if you wanted to. I'm just going to carry on and say, well, let's say that this is x, this is y. What that means is that c to the power of x is equal to a, and c to the power of y is equal to b. I skipped a little bit there, so I didn't write down the initial expression, but this is still true, and I can see it from what's there. And so we're going to start on the other side by saying, let's start with this original expression. Log base c of a over b would be equal to log base c of c to the x divided by c to the y. The exponential rule that we have for this one is that if you're dividing things that have the same base, then we can subtract the exponents, again, as long as things with the base and the exponents, things with the base work, and we're okay with it being real number exponents. So that should be fine. If we believed it last time, we'll believe it here too, which would be c to the x minus y. So we can say we can subtract those exponents and get a single exponential expression in there. Now, what we can do on this point is actually cancel out the logarithm, because the logarithm of the exponential with the same base, same flavor, is going to leave us with just x minus y as a statement in the end. But my x is log base c of a, and my y is log base c of b. So what we've shown here is that if we start with this and we play around with it the right way by doing some substitutions just to make it look nicer, you don't actually have to do it this way, but I find it's a little more clear for me personally to be able to follow along. So I do get this expression in the end that gives me exactly what we started with up here. So this is another logarithm law that we can use to help us manipulate equations that have these things in them. So if you have two logarithms that are being subtracted from each other, they have the same base, you can turn it into a single logarithm. Vice versa too. I don't think I mentioned that in the last one. You can always take a single logarithm that has a multiplication inside of it, split it up into two, or likewise with the division, split it up into two as well. Now, part of this cool property is what makes slide rules a thing. So if you don't know what a slide rule is, that's okay. They were used primarily, anyway, before my time too. But it's really interesting. If you look up some information on slide rules, nifty devices that use the fact that you can turn things like division into subtraction or multiplication into addition. Really cool. Should give that a look if you have some interest in neat math topics. All right, so going to take log base c of a to the n, and this is going to be equal to n times log base c of a. What that means is we're going to be able to bring down the exponent on the thing inside of a logarithm out front as a coefficient. Weird. But we're going to show that this is true. Of course, this is going to lead itself to some peculiar things, like if the exponent on the inside was an even value, of course it's going to fix negatives in the that are inside of the domain. They're going to fix the domain to become positive by squaring it. But if you bring it out front and it's a 2 out front, then it no longer fixes the domain. So there's going to be some funky things we have to pay attention to when we actually go to solve these things. I'll do that in another video. For now, I'm just going to try to show that this is a true statement. So if I said that x was equal to log base c of a, so I'm actually going to start out on the other side there, then it would be true that c to the x is equal to a. Now, if that's how I start things off, I'm actually going to take both sides and raise them to the power of n. So c to the x raised to the n is equal to a to the n. Now, what that means is c to the x times n, because that's actually an exponent law. I have something with base c raised to an exponent x, all raised to the nth power. I can multiply those exponents together and get that statement there. Great. So what I'm going to do then is I'm going to take the left side of my initial equation and say that that is log base c of cx to the n. How do I know that that's true? Well, because it's log base c of a to the n, which I'm now replacing by log base c of cxn. If I take the inverse, the logarithm and the exponential, they're the inverses of each other, they'll cancel each other out. That gives me just xn, which is the same thing as nx, but x is actually log base c of a. So therefore, this thing, and technically this thing, but I should have probably put that inside part was an a to the n, so it is the same as log base c of a to the n. So this thing is the same as that one, which is good because that's what we're trying to show. So we could say that this one's number 3. So log base c of a to the n is equal to n times log base c of a. All right, now, I think I'm just going to actually leave it at that. I might do a change of base as a separate video. I kind of don't think of it as being a logarithm law rule, but you could think of it that way. So I'll do that on its own at a separate point in time. So for now, hopefully, even if you didn't find that really useful, that's at least gives us a little bit of justification for using these particular things down the road. So hopefully that will make us feel a little bit better about logarithm laws. If you found that one helpful, like, subscribe, and as always, take care, folks.